Okay, the real power. That means the power dissipated in the resistors only. You understand? When the current go through the resistor, if you touch it, you can feel it will be hot. That's the thing is electrical converted to the heat. Okay, that's why you get the power. And the power, real power, they get three formula to do the calculation. First one, P equal V times I, or P equal I squared times R, or P equal V squared over R. And the unit of the power will be in watt, R will be ohm, I will be in ampere. And now we get another power. That means the power through the capacitor or inductor. That's what they call a reactive power. Okay? For reactive component, either inductor or capacitor, the product of the voltage and the current, P equal V times I, is measured in the unit of volt ampere reactive. That means the unit for the power in the capacitor inductor, they will be VAR, not the watt. Okay? Watt that means only for the real power, especially VAR are volt ampere at 90 degrees. You understand in the R in the L circuitry or C circuitry. And on the time you can get for the capacitor circuitry, the current leading the voltage 90 degrees. Or in the inductive, the voltage will be leading the current 90 degrees. So that's why they say VAR, that the voltage ampere at 90 degrees are different. Okay? Then now you get another one, apparent power for RLC circuit. The product of the total voltage and the total current, P equal VT times IT, and we call a circuit apparent power. Okay, so that means the power including the real power and also the apparent reactive power. Unit of the apparent power is VA instead watt. That's just a very definition for the real, what is the real power or reactive power or the apparent power. Okay, power in AC circuitry, power factor, PF, for an AC circuit containing inductor and capacitor. The power factor PF is the ratio of the real power in watt to the apparent power in volt ampere. This is expressed as PF, that means the power factor, equal the ratio between the real power, that means the power in the resistor, divided to the apparent power, Vn. Okay? And also, if you want, you can see for series circuitry, PF also equal cosine of the theta Z. Z means impedance for serial. And for parallel, they will be cosine theta of I. I mean the ratio between the current. Okay? Power is the rate at which work is done. Power is energy expended over a period of time to complete useful work. In an electrical circuit, energy moves electrons. This energy is dissipated in the form of heat when electrons flow through the resistance. Electrons that are moving, that means that the current flowing. A watt is the unit of electrical power. Okay, real power is dissipated only in a resistance. Three basic formula like we already telling you. P equal I times E, P equal I square times R, P equal E square divided to R. In this formula, P power in watt, I current in ampere, E in the voltage across the resistance in volt, R will be in ohm. Okay, so three basic formula we already know. This relationship of current, voltage, resistance, and power hold true for A, B, or C. Which one? A, B, or C?
C.
You say C. Who else?
A.
How, man? No. So basically, that basically you're doing left phone will be C again. However, the answer will be B. I already told you, this three formula here only apply for the resistor. Okay? The unit of the power will be a watt. That only resistor. If when you get a capacitor or the inductor, that's what you get another one they call a reactive power. And the unit not be in the watt. Okay? If you're talking about AC and DC, the power, they will be apparent power. So that was three basic definitions for the power you have to understand. Okay? The power dissipated by the heat, that only apply for the resistor. Okay? That means only the DC only. When you get the AC, then the power will be reactive power. Okay? When they combine AC and DC, and the power will be apparent power, as we already tell you. Now, in this circuit, the sine wave of voltage produce a sine wave of the current through the resistor R. As the current and the voltage is slow, by the plot in phase or out phase. So now this will be giving you more picture for the phase difference. Okay, this is the voltage here, and this is the current. The value will be different. However, if we're talking about the phase, both going up, both going down, they will be in phase. Okay, the answer will be in phase. Now, however, if the one going up, the one opposite going down, what is it? Out, out of phase. 180 degrees out of phase. Okay. Otherwise, they just shift to the right. Okay. That means you have to calculate the phase difference. Okay, multiplying the instantaneous current value by the corresponding voltage produce the power curve as so. Okay, so basically you get the voltage and the I. Okay, and you get the calculate the power, and you can see this is the power display here. Okay, if the power curve twice the frequency of the basic voltage and the current sideways. Okay, so I believe the answer will be yes. Okay, they're telling you this is the curve for the power, and this is the curve for the current and the voltage. The average power is indicated by the horizontal dashed line. That means they're telling you that the average power right here. When calculating the average power, is the RMS value of the current and the voltage. So basically, P equal I times E or I square times R or E square divide to R. Okay, now an ideal capacitor inductor does not convert energy to the heat. Okay, so that means on an AC you can touch on the capacitor here, inductor here, you cannot feel hot or warm. Okay, the reactive components store energy delivered to it from the generator, then return that energy to the circuitry. So basically, you apply the power a generator here, you get a sine wave. Okay, positive, you get a power going up, negative going down. They return in here. They not lost anything. For 1/2 cycle of the generator cycle, the reactive component draw energy from the generator. Okay, that means for the positive, they generate the power. Okay, okay. The bandwidth is determined by the upper lower cutoff frequency. You already know. Okay, this is the cutoff frequency minus 3 dB. Okay, and you can get two cutoff points. Okay, F1 lower cutoff, F2 upper cutoff. and this is a frequency domain. Okay, so if you want to calculate the bandwidth, that means the bandwidth here, you take F2 minus F1. Okay, and we already know from resonance selectivity bandwidth of a series ILC circuitry depend on quality Q of the coil. Q calculated by HL divided to the R. Okay, in the last week, last meeting, we already know how to calculate the Q for the coil. Okay, now during all the half cycle, that means this is negative of the sine wave, the reactive component return power to the generator. That means they not lost anything. Okay, in the positive, they create the power. However, in the negative, that power will be returned back to the generator. Okay, that's just a very, very basic. So make sure you need to reading over and over. In general question, you're able to answer it. Not doing calculation here. The power consumption of the reactive component exactly equal the amount of power returned to the circuit. Okay, that means you not get lost anything in the AC for the reactive. Is real power consumed by an ideal reactive component.
Question, Mr. Pham.
Real power.
Question, Mr. Pham.
Yes or no? See that? That's a multiple choice. What I'm saying is when you're doing your left vote, you get through it. But that's not a big deal. If you click yes, they say incorrect. And if you select no, okay. So basically, they just try to teach you to learn. So that's why they've given you a multiple choice. Okay. A or B or C or D. If not A, then they got it. And maybe B. If not B, then C. Okay. However, if first you select A, they say wrong. Then you select B, it's also wrong. And C, wrong. You guarantee D, they will be let you go. However, they will be deduct credit. Okay. That means they supposed to give to you 1 point, and each one they will be wrong, deduct 0.25. Okay, that's what they do. Power not convert into another form of energy, such as heat, equal reactive power. Reactive power that they're using Q. That will be power in inductor or capacitor. Reactive power is the product of the voltage across and the current through reactive component. Unit of reactive power, like we already said, voltage ampere reactive VAR. Remember, unit of reactive power will be VAR, not watt. Watt, that's just a unit for the real power. That power only happens in the resistor only. Okay, now you can see this is a circuitry here. You can get the 10 volt IMF, VR equal 5, okay, VC is 5 VR max. Now, the reactive power of the capacitor C is which one, A or B or C? They given you the formula here. I times VC. VC is 5 VRMS. I will be 2 milliamp. So 2 times 5 will be 10. Okay? So the answer will be A or B or C.
B.
Which one?
B.
B, right?
B.
The thing is you take the 5, 2 milliamp times 5 volt. That's what you get 10. Okay? Milliamp, so that's why you get milli VARF. That means reactive power. That's how they think you calculate the reactive power. In this circuit contain resistance, okay, are here. Capacitor, reactant, HL and HC. The generator must supply both real power for the resistor and reactive power for capacitor and the inductor. So I think that make very clear to everyone. For the resistor, okay, you get the power, real power. For capacitor, inductor, you get reactive power, okay? To determine this generator power, that's what they call apparent power, okay? F. Multiply the generator voltage by the circuit current I. So apparent power equals V times I. So that only try to telling you, if you get a circuitry with only resistor, then you get the real power. When you get a circuitry with either IC or IL, you get power, but that will be a reactive power. Now, if they combine in the circuitry with also R, IC, or IL, then that power from generator, they call apparent power. And there will be V generator times the current I. So what I say is, this is just a very definition. When we asking you, you're able to answer the question. Okay, what is the apparent power? What is the reactive power? Or what is the real power? How to calculate the real power? How do we calculate the reactive power? And what the unit of the real power? What the unit of the reactive power? And finally, apparent power. Okay. Only a percent of generator apparent power is converted to the real power, and this is fed in the circuit resistance at the heat. You understand? For sure, when the current go to resistor, you get the real power. Okay, that only real power. Now, the generator also supply reactive power to the reactive component, which alternately consume and supply power Q. That means Q for reactive power. Okay. The ratio of the real power to the apparent power is the power factor, PF. So what is the PF power factor equal? That will be equal real power divided to apparent power. The power factor is a measure of the real power actually delivered to the circuit from the generator. Okay, the thing is when the generator connect into RHC HL, okay, and they can get the power for the resistor, power for inductor, power for the capacitor. And they want to calculate the power factor PF, okay? And that power factor PF, by definition, they will be equal the ratio between real power divided to apparent power. And that power factor is measure of the real power actually the delivery to the circuitry from generator. How much delivery for the real power. In this circuit, the total power, P total, dissipated at heat is in the resistance R1 and R2. The reactive component draw apparent power from generator during 1/2 cycle of supply reactive power during the other half. Okay. Apparent power supplied by generator is computed from generator voltage and the circuit current. That means S equal V generator times I. Due to the phase shift introduced by the reactive component, the apparent power is greater than the real power. That they can tell you how come you can look the reactive power will be more than real power. The thing is they get the phase shift different. Okay, now on that one, the total real power, P total, dissipate at heat in this circuitry is, you doing calculation telling me A or B or C.
C.
Perfect. C. First one is real power will be happen only on the resistor. So the R1 you get 3 times 1 you get 3. 3 watt. And another resistor you get 1.5 times 1 you get 1.5 watt. And the total real will be adding up. That's why answer will be C. Okay, if you get a question, just let me know. On this one, you can calculate the reactive power. Okay? Let's still V times I. Now, to find the total reactive power, Q using for reactive power. Delivery by the generator. Total the reactive power from each reactive component, plus and minus. So Q will be plus Q of L1 plus or minus Q of C1. Okay, that means they will be opposite. Now, in this circuit, the total reactive power introduced by C1, L, and L1, A or B or C. And you understand unit of the reactive power will be VAR.
A.
Which one?
A. 1 volt amp.
Perfect.
Yes.
Perfect. A. They already given you the formula in the previous. That means you take 3 times 1, you get 3 VAR. And you minus in the capacitor, 2 VAR. Answer will be A. To determine the apparent power, which is the power supplied by the generator multiplied by IMS circuit current. Okay, by IMS generator voltage VG. Okay. Now, in this circuit, they want to know the apparent power is A or B or C.
C.
Which one?
Yeah, C.
C, correct. Now, sometimes they ask the question, I don't have to do anything. I still get the right answer. I don't need to do any calculation. But I see A or B or C, I can say answer will be C. Can you tell me how do I know?
Volt amp.
I say without any calculation in this problem, I can tell you the answer will be C. My question is, how do I know? Answer will be C.
Because of the unit. Volt amp.
Because what?
The unit. Volt
Perfect.
amp.
Perfect. I guarantee this has to be wrong, right? That's a unit what? That's not a apparent power. That's a unit of the real power. VAR, that's a unit of the reactive power. Only thing the apparent power unit have to be VA, voltage ampere. So that's why I say answer will be C. Okay, so basically we can get a very short, okay, lecture for today. This is not much thing to do, not much thing to do calculation also, okay, and you will be do it in assignment and also in the quiz. However, now summarize. You understand the power. They can be applied to the resistor, okay, to the inductor, okay, or capacitor, or they will be combined resistor, inductor, capacitor. So they get a different name, different formula, different unit for each power calculation, okay? And we know the real power apply only for resistor. Reactive power apply for the capacitor inductor. And the unit, they will be a VAR. Okay? And if the circuitry combine RCL, that will be telling you you get the power they call apparent power. Okay? And a unit will be VA, voltage ampere. Okay? And the other thing I want you to make sure, okay, you know the PF, that's what normally they're using. That's what I want you to make sure you know. What is what formula to calculate the power factor, PF? Real power divide apparent power. Okay? So what is the power factor? That is the where they measure of the real power actually delivery to the circuitry from the generator.
Mr. Pham, question.
Go ahead. Question about what?
Reactive power, it says, is only specific to 90-degree phase angle, correct?
Yeah, they get the thing all the time. Inductor or capacitor, voltage and current, they not in phase.
What is
Happen. They different 90 degrees.
then apparent power is the definition of any other definition of a signal's phase angle, apparent power?
No, they don't care.
Doesn't matter.
Apparent power, that means when you can see on the circuitry, you include the real power and the reactive power. Then that power will be cannot be real, cannot be reactive power. The thing is they combine. So that's why they call apparent power.
What is the definition of power available in a circuit for any phase angle from 0 to 360?
What do you mean any phase angle?
Well, if reactive power is only specific to a 90-degree angle,
No, the thing is 90, why 90? You understand the power V times I. V and I on for reactive, they all time will be different 90. You understand that the capacitor voltage IC leading VC 90 or inductive VL leading IL, but they're not talking about 360 degrees. So I cannot answer that question.
right? So I guess my question is, if reactive power is 90 degrees, what would be the definition of 1 degree? What would that definition of power to be?
What do you mean 1 day?
Well, that's my the initial.
That's what I try to explain to you. Okay. When you see the power in the reactive, there will be bigger number than the real power. The thing is what they say, V and I, that's different by 90 degrees. So if you want to go into a more detail on that, I cannot in this program.
Thank you.
Okay, you can go to the college or university. It could be go detail on
Right.
everything.
I understand. Google.
Okay, no problem. Okay, we will be next time. We'll be get to the transformer. Okay, and also I still need to talk to you about RCL circuitry in series parallel. Instead, we're doing the way we did it before. And we can using the complex number. That means if you go to the college university, they will be using complex number. Okay. So now I want to ask you a few things here.
Mr. Pham,
Yeah,
I have a question.
go ahead.
Is there any penalty fee by San Diego Gas and Electric when you have very low power factor in your at home?
What do you mean? Very low power factor.
Yeah, when you have a lot of motor and thing that your power factor is too low in your home or your company.
Now the thing that you see and the definition for the power factor. This one is whatever real power divided to the reactive apparent power. Okay, so what the power factor telling you? If you go in again for what we already telling you.
Yeah.
That's what I said. Try to reading the NO, not one time. Give more time reading over under up to the point you really understand. You see that?
Okay.
Yeah. Basically the ratio between real power and apparent power. That means when you combine RCL, that's what you get apparent power. Power factor is measure of the real power. That means they want to know about the real power actually delivery to the circuit from the generator. So when you get the RCL circuitry, okay, you can get real power. You can get reactive power. And this PF here They just telling you, okay, how to measure the real power, okay? Actual delivery to the circuitry, how many percent real power will be delivery to the circuitry. That's it. Now I add you this thing here. Okay, now if you're looking on this circuitry here, you know that's a generator. RS, what that mean? RS. That will be internal resistance of the generator.
Yeah.
Okay? And now you connect the load IL50O. So you could see, you can try recognize the circuit. Okay, same thing, 10 volt. At 50. L 75. Okay, and then you can get another one here. Okay, what I want you to do, calculate the power, P out, P out, and P out. Do calculation telling me the first one, what you get for the power. You know the formula for the calculate the power. Okay. V times I. So you need to get the current. Then you can calculate the V times I. Do that calculation telling me what the output supposed to be.
2 amps.
First one, which one, what you get? How many watt? Or you can using a V square.
Yeah, this is very.
Okay, so the first one here, what PL you get?
But the resistor is the total or only the load?
They want the output power across the RL.
Okay.
That's what I say. You can calculate I, then you calculate I square times R, L. Or you can even calculate the V out, then V out square divide.
To what?
Mr. Pham, question.
Yeah,
In these circuits right here, you said the RS is the resistance of the generator. So in these calculations, are we to ignore the resistance
no,
of
you cannot ignore. That's the output of the generator resistance.
and not to beat this up too much? So then, since this is like a series circuit, then we would have to add up the resistance then.
For sure. Current will be going this way, right?
Right.
However, you can calculate the V out easier. What V out equal?
5 volts.
5 volt. Perfect. Voltage divider.
250 ohm resistor, so it's half and half.
Right. So 5 square, right? And
I
5.
said it's 0.5.
So what you get P out?
0.5?
Is it 25 watts or what?
0.5 watts. Yeah.
Tell me the second one. That the load will be 75 ohm.
Mr. Pham,
Just a minute. Okay, look like this is not 25 watt.
yeah, because it's 5 squared divided by 50.
Point,
P
0.5, not the
PL square divide to the load IL 50 ohm. So what you think you get?
0.5
0.5 watt.
watts.
Correct.
Yeah, 0.5 watt. This is the correct.
That means I will be given to you here. Okay, 5 square divide to 50 ohm. So what the next? Zero point what?
0.75 watts.
No. Five square, right? No, it's not 5 square. Sorry. You have to calculate the voltage V out. Okay, 10 times,
0.48.
okay, divide 50 plus 75.
Yeah.
125. Okay, so they will be equal.
V out would be 6, right?
10 times
6 volt.
V out would be 6. So 6 squared is 36.
0.48. Okay. 48. Watt.
0.48, that's what I get.
you get it.
Watt.
Okay, I want the last one. How many watt?
0.498 watts.
0. What?
498.
49. Is it just what you get, right?
Right,
Right, sir.
0.4986.
Okay, now, for 3 circuitry, which one will get the maximum power? This is the one.
The first one.
Max,
The first.
Hey, Mr. Pham, if you look at those numbers, the first one looked like it's maximum, but they all right up around 0.5.
what do you mean 25?
No, I didn't say 25. I said the first one's 0.5, the second one's 0.48, which is almost 0.5, and the last
No,
one is
no, just telling you the difference. We're not draw it up. This problem try to bring it up to you. Okay, if you change 75 ohm to a different value, and that will make a quite different. But if you compare between the circuitry, my question is, the maximum you can get is the circuitry number 1. Is it right?
correct.
Right.
Okay, now, what is the difference? The difference here, you get 50 ohm. Load 75 and 45. Okay, the reason you get the maximum power. The thing is you get 50 ohm here and 50 ohm here. That's what they're talking about, impedance matching. That means internal output of the generator 50 ohm. Then you have to be connect load 50 ohm in order to can get the maximum power. Otherwise, the load higher than 50 or less than 50, no matter what, power will be less. That's what they prove it for you.
And Mr. Pham, so the impedance match, the RS and the RL's got to be the same.
Exactly. That means output of the generator and output of the load, they both must be matching. If they not, you lost the power. So when you connect your power amplifier to the speaker, make sure you know what the output load, output resistance for your amplifier and the input resistance for your speaker, they must be matching in order to get the maximum power. Let you understand the transmission between output of the generator to the load. They have to be matching. So that's why when you see on the generator output, they put 50 ohm, right? That means output of the generator will be 50 ohm. So there is in the coil cable that will be get the 50 ohm resistance. So you can get the maximum power from the generator. Now, you learn the transistor, NPN, PNP, and you get the amplifier, CE amplifier, CC amplifier, and CB amplifier. CE amplifier, you want more gain than you want to using CE amplifier. However, CB and the CC amplifier, the gain almost equal to 1. That means basically whatever coming in, coming out, they be the same. They don't have any more gain. But why we get that? The reason is, the CB, you can get either output impedance will be low, okay, or high, or CC, same thing, output impedance, either they can be low or high. So that's why when they design the circuitry, they want the load at a low impedance. They don't want to using CE amplifier. They have to be using either CB or CC. That's regarding to matching impedance. If you try to remember, you get CE, CB, CC amplifier. Okay? How come they can get 3 amplifiers? That's for engineering when they design something. They want more voltage. They want more gain. They're supposed to be using CE, not CB, not CC. However, when they want that amplifier like the load for the other one, and they say, okay, I want high loading or low loading. then they can be either CB or CC. If we want to know detail, you have to go in back to see CC and CB. Which one get high impedance? Which one get low impedance? Okay. So now you can see that important thing is marking. So next time, that will be not long lecture, not much. However, we'll be talking about they using the transformer in order to make a marking impedance. Okay, transformer you can design in order to get the matching impedance. Instead the 75 ohm, and now you can matching it to 50 ohm to get the maximum power. That we'll be talking about next lecture. Okay. Any question? If it's not, then we will start the quiz now.
Okay.
Sounds good.
Thank you.
Okay, so everyone, just make sure you go to the website and just download the report for the quiz 8. Okay, so just make sure you go to the website. I put the link on the chat there, so you can click on that and make sure you download that report. And we're gonna go through the test, and you put your answer there on that answer sheet. Okay. All right. So here we go. Let me go ahead and oops, did I put share? Okay, so let me go ahead and put this one on. Go to share screen. It's here. Okay, let me see. All right, share. All right, so we're gonna be going through. So, okay, here we go. Okay. So can everyone see?
Yes.
Okay, thank you.
Yep.
Okay, very good.
Make sure you know on the question number 2, you need to calculate on the HL. And number 3, HC will be equal HL at the resonance.
Okay, so that's pretty much it. So make sure you upload it to the website before 12 o'clock tomorrow. Okay. Let me see. There's a chat coming in. Anything? Okay. Look like everything's coming good. Okay. So everyone's good. If you have any question, go ahead and ask. If not, then we'll see everybody tomorrow. Okay. You want to see number one again? All right. Let me see. Right, number one. Let me see. Okay, so keep on going. Okay, so there's question number one.
Can I see 36
Uh,
through 40?
36 to 40.
Yeah.
Maybe not another time.
No, it's not in the screen.
Okay, hold on. Let me see. Okay, so we're gonna go to screen, maximize it. Okay, so sorry about that. Let me see. Maximize share screen. Okay, so that's number one. Okay, so that's pretty much it. Like I said, make sure you upload it to the website, and then before 12 noon, and we'll see you everyone tomorrow. Okay. All right.
Okay,
Thank you.
thank
You're
you.
welcome. Thank
Good
you.
night.
Okay,
Good
good
night.
night.